Hi team, welcome for a walkthrough of the Delta Math concepts today. And the Delta Math covers a lot of the things that we reviewed in the beginning, as well as completing the square. So you're going to take a look at some of these examples. First of all, I just want to get people some practice reading vertex form. So if we're looking at an equation like this, we can very quickly read off what it will look like in vertex form. So here, I can see that this is an a value of -2, but you don't need that to answer these questions. You just need to be able to identify where the vertex is. So -2, 5 is the vertex. So if -2, 5 is the vertex, this one will do it. -2 becomes a +2 there, and +5 is still +5 over there. However, this one is a parabola that opens upwards. It has an a value of 2, and I want an a value of a -2. So this one here will be correct. Submit answer, and it will tell me green check mark, hooray! And I do this. Do that at least mentally and be thrilled that you got the right answer, because that will help your practice. And then you come down and you say the vertex form is this, where the vertex is at h and k. The parabola opens downward, so we have a negative a value, so we want this -2 here. And then if you had x minus -2, that would be x plus 2. Just remember this is a sign flipper, and you will get the same thing. Okay, so that's how you do that skill, and I had you do several practice problems there. They're fast. Then vertex to standard form. Here, we want to do what we were practicing earlier today, and I think we did an example almost exactly like this one. Where if I have y is equal to -3 multiplied by x minus 4, all squared, minus 8. I want to be able to express that in standard form. I mean, I could sketch it, and I could guess what it is in standard form. It's going to be a vertex here at +4, -8. It opens downwards. This is going to be, and it's got a stretch factor 3, so it's going to be something like that. And that's what I just know from looking at the vertex form. But I want to expand that into standard form. So let's do that. Your y is equal to, do this last, -3. Leave it alone for now. Write out your x minus 4 twice. This is writing that exponent as a repeated multiplication. And then subtract 8. Use your FOIL rule. So now this is y is equal to -3 times x squared minus 4x minus 4x. It's minus 8x. Then minus 4 times minus 4 is positive 16. Minus 8. Okay. And now I can multiply in this 9 minus 3 and multiply it by all the terms. There's 3 terms there, multiply it by 3 terms. So y is equal to -3x squared plus 24x minus 3 times 16 was that minus 48? Yes, minus 48. Minus 48 minus 8, so that would be minus 56 altogether. Y is equal to -3x squared plus 24x minus 54. Oops, this way. Minus 56, sorry, 56. And then you can check that quickly in Desmos before you put it in, or you can just be confident and put it in here. -3x squared plus 24x minus 56. Submit answer. Yes. Hooray! We got it. So how did you do that? Well, they did the same thing. Look, they wrote that out. They do this. They show you that step, and I didn't show you that step. I went straight to that step. Then they multiply in the -3 by all those 3 terms. Boop, boop, boop. We got that too. And then one last thing is collect these like terms. There's no x's there, so they're like. That's like -$48 minus another $8 is minus $56. All right. So now that's one other problem type that I want you to do some practice with. And then we're going to practice going the opposite direction, being given an equation in standard form and rewriting it in vertex form. Oh, and they started with a tricky one here. A tricky one. All right, let's do it. Okay, so if I want to complete this square, I'm going to have y is equal to, I'm going to write out the question in my notes, x squared minus 9x minus 4. And now I'm going to notice that I have an a of 1, so I don't need to factor out a here. So I go straight to finding my Jerry-Maguire number, so it's going to be x squared minus 9x. Then I take -9 and divide it by 2 and square the result. So that's going to be 81 over 4. So I'm going to add 81 over 4. And if you prefer to see that as a decimal, that's 21.25. Sorry, 20.25 is that number. 81 over 4, 20.25. Okay, here I would have negative 4.5 squared, and 4.5 squared will be 20.25. So that's equal to 81 over 4, or 20.25. I find this number easier to work with, but I'll use this one because I know you like it better. So here, and I've shown a lot of fractional answers already, 20.25. And then I'm going to, that's my perfect square, minus 20.25. I don't have to do anything special to that number because a was 1, so it can come out no problem, minus another 4. Okay, and so now write it out again. Y is equal to x minus 4.5. Okay, that's this number, negative 4.5. 9 divided by 2 is 4.5. Square it, minus 24.25. Now check your answer in Desmos before you submit it. So this is what checking it in Desmos looks like. I go over here, and I'm just going to graph the original one, which was x squared minus 9x minus 4. Okay, there it is. And then let's check the vertex. 4.5, negative 24.25. Negative 24.25 is there, and positive 4.5 is there. Great, hooray! I'm 100% confident that this works. Notice this one also doesn't factor over the integers. It's got some weird radicals in there that you could find with quadratic formula. Okay, so where is my delta math? There it is. Okay, so I'm going to put that in here. Y is equal to x minus 4.5, 4.5, and brackets, square it, and then minus 24.25. Okay, and let's say submit answer. Do I want to submit that answer? Yes, I'm very proud of this answer. And it says, yes, hooray. Okay, so they did b over 2. They're doing decimals over here as well in their answers. Boop, 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 minus 4. So there's their perfect square. You see they have that perfect square. Factor the trinomial is a perfect square. Binomial, x minus 4.5 squared is this. That is that, just rewritten in a new form. Then they minus 21 minus that. That's what they get, and then we got that too. Okay, let's see if it will take a... Oh, that one, I don't need fractions. This one is, let me do it in my head. This is x plus 4. And then I have to subtract 16. Oh, this is squared, don't forget. Subtract, so this is minus 20. Okay, submit answer. Yes. Hooray! Okay, let's do another one. There we go. So let's do this one, but we'll do it with fractions and see if it likes the fractional answer. So am I going to do it in my head? No, I'll write this one down for your benefit. So I'm working with fractions. This is what it's going to look like. I'm going to take that 9, and I'm going to have x squared plus 9x plus, and this will be 9 over 2 squared, so 81 over 4 minus 81 over 4, same Jerry Maguire numbers we had before, minus 2. Okay, and this is equal to, where'd I get this number? That's 9 over 2 squared equals 81 over 4, this number here. Okay, so that's where I got that number. Now, let's do it. This is equal to x plus 9 over 2 squared minus 81 over 4 minus 2. So minus 2 is like saying minus 8 over 4. Is that an 8 now? Sure, if I do enough loops, that will be an 8 over 4. So it's a minus 81 minus 8, so that's minus 89 over 4. Okay, let's see if it likes this answer. X plus 9 over 2 and brackets squared. Oops. No, you got to put your brackets in the right spot. So there is my bracket in the right spot. Squared minus 89 divided by 4. The answer. Yes, I'm very proud of this answer. I submit it, and it will like it. It likes it just fine. It's showing you a solution where they use decimals. Mine is with fractions. No problem. Same thing. Okay, so that's those types of problems. And then this one, standard vertex form type 2. All it's going to ask you to do different in this problem type is to tell it what the new vertex is. So So you have to be able to read your vertex form equation and say, now I know that the vertex of this quadratic is boom here. So let's do this one. I'll do it in my head for you. So this is x minus 5 squared, x minus 5 squared, and then I have to add and subtract, plus 25. And the vertex is going to be at 5, 25. Pretty sure. I'm not going to check it, so I might be wrong here. Let's see. No, I'm correct. Cool. All right, so that's how you do these. So this one, all you need to do is write out the equation in vertex form and then read where the vertex is. So there I have minus 5. So that's positive 5 in the x. And then this gives me the y value of the vertex, or the optimum value of the parabola at 25. These are all the questions that I have in the Delta Math for you. More practice of these methods. You want to get some wins under your belt today where you're, okay, I can complete the square now. I can do this. Or if you're having trouble, you get to look at the Delta Math solutions and see, what did they do? Where did I go wrong? And what question can I ask Mr. Jennings so I can get this topic to click? This is the only really new topic this week. It's a tricky one. I think people will agree. I think it's pretty tricky. Yeah, it's pretty tricky, but once you can do it, you can do it. Great. So get going on your Delta Math, everybody.